Good afternoon, class. We are looking at section 3.4, the product and quotient rule. So we looked at the first two sections, derivatives and rates of change, the derivative as a function, where we have to use the definition f prime of x is limit of f of x plus h minus f of x over h as h approaches 0. Basic differentiation formulas in the previous section, and now the product and quotient rule, and we don't need to use the definition. And so reminding everybody of rise over run, delta y over delta x in various formats, y sub 2 minus y sub 1 over x sub 2 minus x sub 1, or f of x minus f of a over x minus a. In this case, f of a plus h minus f of a over h, b f of b minus f of a over b minus a. All of them are giving us the slope of a line known as a secant line. As q approaches p, we get to a tangent line. So the tangent line is the limiting position of a secant line PQ as q approaches p, and we can see that as instantaneous rate of change. So if we look at this one, q approaches p. If we look at this one, x approaches a. If we look at this one, h approaches 0, and we call it f prime. Various formats for lines use the point slope at point a comma f of a. Here's the equation of a tangent line, y minus f of a equals f prime of a times x minus a. We'll just use the point slope. In general, it gives rise to the definition f prime of x is limit of f of x plus h minus f of x over h as h approaches 0. So that's what we looked at. And now the product, again, this is the definition, these two. This is the constant multiple. This is the sum and difference rules. These are various formulas. We've seen the first few, and we will look at the rest of them later on. You got to be very comfortable with those. And now we are adding the product and quotient rule. The derivative of f of x times g of x is f prime of x g of x plus g prime of x f of x. The derivative of f of x over g of x is f prime of x g of x minus g prime of x f of x over g of x squared. This is the shorthand notation. Class, the order by which you've seen those may be slightly different. This is the faster and easiest way to memorize. If you've learned them differently, you can follow that. I hope you're interested in learning the easier way. Notice f g prime is f prime g plus g prime f. F over g prime, the numerator uses the same thing, changes plus to a negative sign. Now, as far as the product rule is concerned, class, the proof, I have it at the end of the PowerPoint. You're more than welcome to look at it. But for now, we are going to look at a couple of interesting stuff. First of all, by analogy with the sum and difference rules, one might be tempted to guess that the derivative of a product is the product of the derivatives, which is not the case. We can see, however, that this guess is wrong by looking at a particular example. If you want to disprove something, class, all you have to do, one example disproves it. But if you want to prove it, that's not the case. So an easy case, if f of x is x, g of x is x squared, by the power rule, the derivative for this one is 1, for this one is 2x. Very simple. If you multiply them, you get x cubed. And you know the derivative of the x cubed by the power rule is 3x squared. But if we multiply, and if we go with that rule, if we multiply these two, we get 1 times 2x, which is 2x, and that's not the answer, clearly. So that definitely fails. That means fg prime is not f prime g prime. However, again, this is a shorthand notation, and before I go over that, class, this is probably what you've seen. If f and g are differentiable, d dx of f of x gx is f of x d dx of g of x plus g of x d dx of f of x. That's absolutely fine. Whatever you've learned, it works perfect. To me, when I go with this route, it makes it easier for me to do the quotient rule. In any event, f prime g, g prime f, look at this one, f prime g 1 times x squared plus g prime f 2x times x. and they add up to 3x squared, which is the same as here. So as you can see, an example shows that it works. Again, it's not a proof. I do have the proof at the end of this part. Now, when I say find the derivative both ways, I mean one is just to distribute and use the power rule. The second one is do not distribute, use the product rule. Both of them must give you the same answer. Okay. Now, this is a warm-up example, which means I'm not going to finish it up. I just want to show you how easy it is to follow the rules. So if I'm doing this as a part of homework or exam, first I'm going to write the formulas I need from the memory, okay? Not from the PowerPoint or notes or anything. From the memory, I write this formula, and I'm going to go with f prime g plus g prime f. So this is f. F prime is 4x cubed minus 6x squared times g, 3x squared minus 5x. So f prime g plus g prime 6x minus 5 times f x to the power 4 minus 2x squared minus 7. Granted, this is not finished, but this is the only calculus step. The rest would be a bunch of algebraic steps for you to finish. Now, let's actually look at examples. We are going to go from A to Z to finish him. So h of x is x times e to the power of x. And to emphasize that, I put a raised dot in between, meaning I'm multiplying these two, meaning I need to use the product rule. So I'm going to write f times g and use the product rule. F of prime is 1 times e to the power times e to the power of x. So f prime g plus g prime is e to the power of x times f, which is simply x. And I put it at top just to emphasize how we arrived at the answer. So this is f prime g plus g prime f and we can factor e to the power of x out. We get e to the power of x times 1 plus x. Find h double prime, which means then you want to differentiate this again, and I'm going to write this as f times g again and use the product rule again. So f is e to the power of x. F prime is itself times g, which is 1 plus x, or x plus 1 makes no difference. Plus g prime, the derivative of the parentheses, is just 1 times f, which is e to the power of x. And I'm going to write at top of it so it becomes clear as to what we have. So we have f prime g plus g prime f. Now, if I take e to the power of x out, I get x plus 1 from the first one, 1 from the second one, and we get e to the power of x times x plus 2 as the final answer. What about y equals x squared sine x? Again, we put a raised dot in between to emphasize this is using the product rule, everybody. And therefore, this is f times g. F times g, where f is x squared, g sine x. So we're going to use that. So we need f prime, which is 2x. Times g, just sine x. Then we need g prime, the derivative of sine is cosine, times f x squared. You're done with calculus. You must move the x squared in front because this is awkward and one may think this is x cubed, which is not. So put the x squared in front. You don't need to factor the x out. It makes no difference. So that's the product rule, everybody. And now we're going to look at the quotient rule. Again, a warm-up example. And I'm going to call this f over g. And notice f is the same as f for the product rule warm-up. G is the same as that one, but this time we are using the quotient rule. So to use the quotient rule, again, I would write the formula and I would follow that. I need f prime. That means I need the derivative of the numerator. We've seen that derivative to be 4x cubed with the minus 6x squared. Times g, just write the blue function next to it. Minus g prime f, g prime minus the parentheses, 6x minus 5. F is the top function, the red function, put it next to it. And for the bottom, just a huge fraction bar. And g squared, that means just write the denominator in a parentheses and square it. Now, of course, this is not done, but the calculus part is finished. You have to simplify this by distributing or folding the top in each case and add up like terms, take it from there. I'm going to leave it for you to finish it, but this emphasizes the most important part, which is the calculus part. All right, so this is f over g. We are following the rule. F prime 2x minus 3 times g, just write the bottom function x minus 1 minus g prime, which is 1, times f, which is the top function, x squared minus 3x. And you just put the g, the bottom, and square it. And we're done with calculus. Now we are going to do a couple of steps to finish the job. First, the denominator, we don't touch it. This one we distribute. Clearly, we get the following, everybody. This is 2x squared. This is minus 2x minus 3x. They add up to minus 5x. This is plus 3 minus x squared plus 3x. And now these two add up to x squared. These two add up to negative 2x. And we are done. I want to explain why. Number one, the top can't be factored, period. I'll show you why. Number two, even if it can be factored, You need a factor of x minus 1 to simplify it. So how do we know it can't be factored? Recall. Here's the quadratic formula, ax squared plus bx plus c equal to 0. And x is minus b plus minus the square root of b squared minus 4ac over 2a. B squared minus 4ac is called the discriminant because it gives us a lot of information. When b squared minus 4ac is positive, there are two distinct real solutions. The solutions will be rational if the discriminant is a perfect square and irrational otherwise. B squared minus 4ac is 0, we have one real solution, which is obviously rational. B squared minus 4ac is less than 0, no real solution. We have two complex solutions in the form of a plus minus br. If b squared minus 4ac is the perfect square number, then ax squared and bx plus c can be factored. Now, as we look at this one, a is 1, b is negative 2, c is 3. So a is 1, b is negative 2, c is 3. So b squared, negative 2 quantity squared minus 4 times a, which is 1, times c, which is 3, adds up to negative 8. Negative 8 puts us in this area, no real solution to complex solution, let alone factoring. Obviously, when there are two complex solutions, that means it can't be factored out either.